Hello there, I'm Mike Levis with the Mount Hood Ski Patrol's Avalanche Program, and today's topic is avalanche accident statistics. Let's dive into it. Our goal in this module is to provide a brief overview of avalanche accident statistics in the United States and to try and answer two key questions. Who is the typical avalanche victim, and what factors affect avalanche survivability? Much of the data we're going to be looking at today comes from the Colorado Avalanche Information Center. This is a resource that tracks accident statistics in the U.S. I would encourage you to bookmark this URL shown in the slide and check it out when you get a chance. Before we dive into the material, what can you notice about this photo other than the large slab avalanche? Did you see the people in the upper left? What decisions do you think these people made to avoid becoming a statistic? When we talk about avalanche survivability, rule number one is not to get caught in an avalanche to begin with. So let's talk a little bit about avalanche potential versus avalanche hazard. It's helpful to think about risk. We'd like to think about in terms of avalanche potential, could a slope slide, and avalanche hazard, what are the consequences of a slide? You may recall from our discussion of the avalanche triangle that these are exactly the parameters modeled by the triangle. Avalanche potential, can it slide, is influenced by terrain, snowpack, and weather, the size of the triangle. And avalanche consequences impact the elements on the inside of the triangle, people and property. So the consequences can be severe. As you see from these slides, property damage can be significant and loss of life can be significant from big avalanches. If you spend any time on YouTube looking at avalanche videos, you frequently see skiers, snowboarders, and snowmobiles triggering an avalanche and then appearing to outrun the avalanche. Usually their path is to the side out of the slide path. While this looks impressive, the statistics would indicate this is not likely the case for most avalanches. Avalanches are typically large, half the size of a football field and 1 to 2 feet deep, and very quickly get up to high speeds, 80 miles an hour in about 6 seconds. The slab shatters like a pane of glass at around 220 miles an hour. You're just not going to be able to outrun a slab moving that fast. So what are the chances of surviving if you get caught in an avalanche? As you'll see in the following slides, survivability depends on several factors. How deeply are you buried? Are you wearing a beacon? Were you injured in your avalanche? How quickly were you uncovered? The first key statistic to keep in mind is that 20 to 25% of avalanche victims are killed by trauma before they're buried. Remember rule number one? Don't get caught in an avalanche. This slide shows the probability of survival as a function of time buried. Note this is only for victims that are not killed by blunt force trauma in the initial avalanche. The thick red line is a 50% survival point. As you can see, for our maritime snowpack with heavy wet snow that sets up like concrete, the 50% survival point is roughly 15 minutes. Regions with lighter, drier snow have 50% survival times of 20 to 30 minutes. So if you think about a typical burial scenario, we have 15 minutes to locate the victim and dig them out before their odds of survival have dropped by 50%. Seconds really do matter in these rescues. The next slide shows similar data from the Swiss Avalanche Institute. The conclusions are consistent. 50% reduction in survival after 15 minutes. Keep these numbers in mind. This slide indicates the timing of avalanche accidents throughout the year. No surprise here, accidents happen in those months of the year with the heaviest snowfall. 85% of the accidents occur in the December through April window. Please note this is North American data, so the profile might be different in other parts of the world. If we look at the age distribution, this slide shows the age distribution of avalanche accident victims. As you can see, most victims are in the 20 to 30 year age range. This slide shows where most avalanche accidents happen in the United States. As you can see, the bulk of the accidents happen in 8 states: Colorado, Alaska, Washington, Utah, Montana, Wyoming, Idaho, and California. These are where most of the backcountry outdoor activity occurs. So no surprise, this is where you're going to find most of the avalanche accidents. This slide shows the activity profile for avalanche accidents. Backcountry ski tour, snowmobiles, climbers, and side country riders account for the bulk of the accidents. This slide is particularly interesting. This slide shows that 2/3 of avalanche accidents involve victims that are not wearing beacons. As the slide notes, this is similar to statistics of drowning victims who aren't wearing PFDs. The slide indicates ignorance is a leading cause of avalanche death. Really, I think it should be carelessness. If you're out in avalanche country and you're not wearing a beacon, it is just carelessness. This slide shows the avalanche fatalities over time. It indicates, if data clearly indicates there's been a steady growth in fatalities over time. The slide also indicates where avalanche beacons first became available. You can see the modern beacons, the digital 3-antenna beacons started to become available in 1991. So they've been around about 30 years now. We might ask why the level of accidents seems to be increasing even with the wide availability of beacons. The answer to this has several dimensions. Firstly, as the previous slide indicated, 2/3 of accident victims are not wearing beacons. So even though beacons are widely available, people are not using them enough. Secondly, the number of people participating in backcountry activity has been growing rapidly. More people in the backcountry means more people in avalanche accidents. Thirdly, and as we'll cover in more detail in the human factors module, there's an increase in risk tolerance as training and safety equipment becomes more available. Things like AVI-1 training, beacons, and airbags increase safety margins for backcountry activity, so people increase the risk level of their activity correspondingly. This slide shows the survivability probabilities as a function of burial time and depth. Look at the circle on the lower left. The data shows that the likelihood of survivability increases significantly if the burial depth is shallow, less than 1 meter, and time of burial is short, less than 15 minutes. So the dots on this are burial victims that were found alive, and the X's are burial victims that were found dead. The lesson here is that things like avalanche airbags and beacons can increase the likelihood of survival by reducing burial depth and time. Also note that implicit in this is that people traveling in the backcountry practice using their beacons so they can quickly find a member of their party if they get caught in an avalanche. So there's a caveat in all this data. Many accidents, particularly if there's not a fatality, are not reported. So the level of avalanche accident activity is believed to be much higher, just not reported. The reported data is probably skewed toward fatalities. So that's the picture in avalanche accident statistics. The bottom line is the best way not to become a statistic is not to get caught in an avalanche to begin with. And this brings us back to the avalanche triangle. Terrain. Is the slope steep enough to slide? Snowpack. Is there a consolidated layer over a weak layer? Weather. Has the weather been changing rapidly as in a lot of new snow over a short period of time to increase instability? So that's our avalanche accident statistics module. I look forward to seeing you in future modules.